Hi everyone, we are from Group 4. We present to you SMN1, SMN3043 Ordinary Differential Equation. Group members are Roslina binti Rosli will do question 1.A, Nur Syafiqah binti Shaharuddin will do question 1.B, Nur Izwana Rabiatul Adawiyah will do question 2.A, Brittany Viola Christopher will do question 2.B, and I am Melanie Anak Josh as video editor.
Assalamualaikum and hello! My name is Roslina binti Rosli and today I would like to discuss about question 1A. Before that, let's go through the question 1. A steel bar weighing 2 pounds is dropped from a height of 3,000 feet with no velocity. As it falls, the ball encounters a resistance numerically equal to V over 8 in pounds, where V denotes the velocity of the ball in feet per second. Find the limiting velocity for the ball and the time required for the ball to hit the ground. Before we proceed to the solution of this question, I would like to explain about how the question wants us to solve. Let's go through. From the figure shows, a steel bar is falling at height of 3,000 feet into the ground with air resistance. Based on this situation, it applies falling body motion, which is occurs in Newton's second law. What is Newton's second law? Newton's second law is the net force acting on a body is equal to the time rate of change of the momentum of the body, which is the equation of F equal to mass times acceleration. Based on this situation, there are two forces acting on steel bar. Firstly is the weight given by mass times acceleration of gravity. Second force is due to air resistance, which is F equal to negative kV. K is the constant of proportionality and V is the velocity. Why negative sign? Because force due to air resistance opposes the directions of velocity, which is on the upward direction. Based on the question given, we already know that weight is 2 pounds. So we can get the mass of steel bar, which is 1 over 16 slug. Now, to find the solution for question 1A, which is the limiting velocity for the ball, we need to know the net force of the steel ball. The net force of the steel ball is F equal to W minus kV. Since the acceleration is the rate of velocity, therefore we substitute dV over dt into the acceleration. Thus, we get the equation in standard form, which is dV over dt plus 2V equal to 32. Since the question given, we already know the value of constant of proportionality, mass of steel bar, and acceleration of gravity. Therefore, we substitute those values into the equation. From the previous equation in standard form, we have to use an integrating factor. There are 5 steps to use an integrating factor. For the first step is the linear differential equation. So, from the previous equation in standard form, we have to comparing the linear differential equation. And for step 2, we identify Px and find the integrating factor of Vt. We achieve Px from the previous steps, which is Px equal to 2. Now, we integrate the factor of Vt, which is Vt equal to exponent power of integration of 2. Thus, we get Vt equal to exponent power of 2t. For step 3, we multiply the equation in step 1 by Vt. Thus, we get this kind of equation. For step 4, the left hand side at the equation in Step 3 is the derivative of the product of Vt and V, which is we get those equations. So from equation in step 4, we have to integrate both sides of the equation in step 5. When we integrate both sides of the equation, we get the final Vt equal to C exponent power of negative 2t plus 16. T is represent the time for the stable to fall, which is t less than infinity and more than negative infinity. Initially, from the question, we already know that there is no velocity at time 0. So, we substitute 0 velocity and 0 at time into the equation. We get C equal to negative 16. When t is equal to infinity, we will get the limiting velocity for the steel ball, which is 16 feet over second square. That's the final answer for question 1A. Let's go through the question 1B.
Okay, next is B, the time required for the ball to hit ground. From A, we get this equation, which is Vt equal to negative 16 e power of negative 2t plus 16. From the question, the ball dropped from a height of 3000 feet. We assume as x equal to 3000 feet, and we get xt equal to 3000. Alright, we express Vt as dx over dt, and then integrate dx over dt. We get xt equal to negative 16 integrate e power of negative 2t plus integrate 16. We get xt equal to negative 16 multiply 1 over 2 e power of negative 2t plus 16t plus c1. Okay, c1 as a constant, so we get the equation like this. Okay, then to find a constant, use the fact that x equal to 0 when t equal to 0. Substitute t and x into the equation, and we get a constant which is c1 is negative 8. So the equation will become like this: xt equal to 8 e power of negative 2t plus 16t minus 8. After that, substitute xt equal to 3000. So the equation become 3000 equal to 8 e power of negative 2t plus 16t minus 8. Okay, replace minus 8 to the left, so 3000 plus 8. And we get 3008 equal to 8 e power of negative 2t plus 16t. So divide by 8, we get 376 equal to e power of negative 2t plus 2t. The solution is an implicit solution. Assume the value of exponential is negligible. So 376 equal to 2t. Okay, so t equal to 188 seconds. Thus, the time required for the ball to hit ground is 188 seconds. Okay, that's all.
Question 2. A 50-gal tank initially contained 10 gal of fresh water. At t equals to 0, a white solution containing 1 pound of salt per gallon is poured into the tank at the rate of 4 gal per minute, while the well-stirred mixture leaves the tank at the rate of 2 gals per minute. Now we need to find A. The amount of time required for overflow to occur, and B. The amount of salt in the tank at the movement of overflow. A. The amount of time required to overflow to occur. Here we have A is equals to 0, B is equal to 1, E is equals to 4, F is equal to 2, initial volume is equals to 10, and the volume is equals to 50. By using this formula, initial volume plus ET minus FT equals to 50, we will have 10 plus 4T minus 2T equals to 50. plus 2t equals to 50, and we will find the t, which we have 2t equals to 50 minus 10, which we will get 2t equals to 40, hence we will get t equals to 20. Now, therefore we will have the amount of time required to overflow occur is 20 minutes.
So we get t equal to 20 minutes from the answer of 2a. And then we know the equation is xt equal to 20t plus 2t squared over 5 plus t. Then we substitute 20 minutes into the equation, then we get 48 pounds.
Thanks for watching.